So I was looking at the spec sheet for this NTI VOPEX-M12V-4 this morning, and I mean, if you drop this thing, I'm pretty sure it would break the floor.
Oh, absolutely.
It's listed as a VGA splitter, but that really feels like calling a tank a commuter vehicle.
Yeah, that's a good way to put it. It's definitely not that beige plastic dongle you've got rattling around in a junk drawer. This is a piece of hardware designed to survive, well, maybe not the apocalypse, but something almost as harsh.
Like the New York City subway system.
Exactly. Or a factory floor.
But let me play devil's advocate for a second. It's what, 2025?
Yeah.
Why are we still engineering tanks for VGA? I mean, why haven't mass transit and industrial manufacturing just moved to HDMI or DisplayPort like the rest of us?
It does seem counterintuitive, doesn't it? But, you know, in the industrial world, newer isn't always better.
Okay.
Think about HDMI. It requires that digital handshake, right? The screen talks to the source. They agree on encryption, resolution, all that. If that connection wiggles for even a millisecond.
The screen goes black and has to renegotiate the whole thing.
Right. Which, if you're watching a movie, is just annoying. But if you're a train conductor looking at critical track signaling,
It's a complete disaster.
a disaster. VGA is analog. It's dumb in the best possible way. It just blasts the signal out. If the connector vibrates a little, you might get a flicker, but you don't lose the image.
Okay. So reliability over resolution. That makes sense. But you still can't just drag a standard VGA cable 600 feet across a factory. The signal would just turn into a mess.
Yeah, it would be a ghost. Yeah, the physics just don't work.
So how are they actually moving the pixels?
Well, that's where the extender part, the VFX name, comes in. It's really a transmitter. It takes that analog VGA signal and it converts it to run over twisted pair copper.
So like standard C6 Ethernet cables.
Exactly. You have the main broadcast unit, the VOPEX at the computer, and then you have these little remote units, the Extend-X receivers, at each and every monitor.
And that lets you push a pretty high resolution signal, right? Something like 1920 by 1440.
A very clear 1920 by 1440, up to 600 feet away.
That's massive. That's like, what, 2 football fields?
It's a huge distance, and notice it supports audio, too, but not through some flimsy little 3.5 millimeter headphone jack that'll pop out.
I saw that. You use terminal blocks, for anyone who hasn't seen them. These are those industrial screw-down wire clamps, right?
Precisely. You strip the wire, you put it in, and you screw it down tight. You could practically hang the device by those audio cables, and they wouldn't pull out.
No accidental yanking.
Zero. And speaking of yanking, we have to talk about the main ports. I mean, where the Ethernet cable would normally click in, there's this heavy-duty, circular, metal-threaded port.
The M12 connectors.
This is the star of the show, that little plastic clip on an Ethernet cable. It's fine for an office, but put that on a train car vibrating down the tracks.
It's going to snap or wiggle loose in a week.
Or a day. So the M12 is the solution. You don't plug it in, you actually screw it in. It creates an airtight, vibration-proof seal.
And the spec sheet mentioned they are A-coded. Is that just marketing jargon?
No, not at all. It's a physical keying standard. A-coding is for sensors and device power and automation. The pins are arranged so you literally cannot plug the wrong cable in.
So it's basically idiot-proofing for high-stress environments.
You got it. Which brings us to the environment itself. The durability stats are just wild. The operating temp is minus 4 degrees Fahrenheit up to 158 degrees.
Wow.
Or minus 20 to 70 Celsius. So think about that. This box can sit in an unheated shed in a Chicago winter or inside a steel enclosure in a boiling factory, and it just keeps working.
And then there's the MTBF, the mean time between failures. I saw the number and had to grab a calculator. It's 593,095 hours.
Yeah.
That's over 67 years.
67 years. That number tells you everything. Consumer electronics are built to last 3, maybe 5 years. This is built to be installed and then completely ignored for a lifetime.
Because downtime isn't just an inconvenience.
In an airport passenger info system, it's a logistical nightmare.
It really reframes how you look at old tech. You know,
Yeah.
we think of VGA as obsolete, but in this context, it's not about being cutting edge. It's about being unkillable.
Exactly. It's the difference between a race car and a freight train. One is fast, sure, but the other is just unstoppable.
That seems like a perfect place to leave it.
Yeah, just one last thought for you. The next time you're on a subway or a train and you see that digital sign telling you the next stop is Main Street, don't just read the text. Think about the invisible infrastructure behind that screen. Think about the ruggedized, vibration-proof, A-coded engineering that's required just to keep that simple image stable while the whole world is shaking around it.
I don't think I'll ever look at a subway map the same way again. Thanks for tuning in to this deep dive.